Hello viewers, I am Kausalya. Today we are going to discuss about frequency response. There are various plots which are used to find the frequency response. First we are starting with Bode plot. So what is a Bode plot? It is a frequency response plot of the transfer function of a system. That is, a transfer function will be given to us. From the transfer function we are going to draw the frequency response plot. Right. And next is Bode plot has two graphs. One is magnitude graph and another one is phase angle graph. I will show the typical diagram of a magnitude plot and phase angle plot now. So this is the typical magnitude plot of a Bode plot. Here magnitude are usually represented in terms of dB. It is known as decibels. And the magnitude symbol will be, it is represented using the letter A. Right. And here comes the phase plot. This is how a typical phase plot will be. Right, we will be having a plot like this. So again, for drawing the phase plot in y-axis we are having angles. Right. So what about the x-axis here? As we are dealing with frequency response, here the frequency comes in the x-axis. So it is represented as log omega. As we all know, omega is nothing but 2 pi f. So there lies the frequency. Right. This plot can be drawn for both open loop and closed loop transfer function. So now we are going to discuss with an example. So this is our given open loop transfer function. Right. So the first step is we have to replace the s by j omega. So in the place of s, you can write j omega. So here we had written that k1 plus st1 in the place of s, we should write j omega t1 divided by, in the place of s, we have to write j omega. And again here 1 plus st2. So in the place of s, again we have to write j omega t2. And 1 plus st3 is written as 1 plus j omega t3. Right. This is our foremost step. The next thing is we have to write each and every term in terms of magnitude and phase angle. So here you see k is a constant. So constant doesn't have any angle. So k with an angle of 0 degree. Next, look at this term. How to write magnitude expression for this term? It is nothing but square root of real term plus imaginary term. So here square root of 1 square plus, here the coefficient of imaginary term is omega t1. Right. So here omega t1 the whole square. So this is our magnitude expression. Next we are moving to the angle. How to write the angle? Tan inverse of imaginary coefficient divided by real term coefficient. So here this is the coefficient of imaginary term. So tan inverse of omega t1 divided by, here the real term is 1. So here omega t1 divided by 1. Right. And the next step is we are moving to the denominator. So here lies j omega. So the magnitude is omega and the angle is 90 degree. Whenever we are having a j, it represents an angle of 90 degree. Right. Next we are moving to the second term. How to write the magnitude here? Again square root of 1 square plus omega t2 the whole square. You see here I had written that. And how to write the angle? Again tan inverse of imaginary coefficient is this omega t2. So tan inverse of omega t2 divided by the real term is 1. Right. And when you consider the last term here, you see 1 square root of 1 square plus omega t3 the whole square, and angle is tan inverse of omega t3 divided by 1, which is nothing but omega t3. Right. Next we are going to write magnitude alone. So magnitude of g of j omega is written as, now we are writing only magnitude. So here k square root of 1 plus omega t1 whole square can be written as omega square t1 square, and here this omega, and here again 1 plus omega square t2 square, and again this term square root of 1 plus omega square t3 square. So magnitude gets over here. The next one we are going to move with the phase angle. So here phase angle can be written as, you see in the numerator I am having 0 degree. So we can leave that one. The remaining angle is tan inverse of omega t1. Right. So here I had written tan inverse of omega t1. And denominator, I am having an angle 90 degree, right? When I move this denominator to the numerator term, here the angle will be minus 90 degree. So here I had written minus 90. And again, when I move this tan inverse of omega t2 to the numerator side, what happens? We have to write it as minus tan inverse of omega t2. Similarly, here tan inverse of omega t3, when it is moved to the numerator, here I will be having tan inverse of omega t3. Right. So, in this video, we have learned how to write magnitude and phase angle expression for a given transfer function. Right. Hope you people understand well. Thank you.